Good day everyone. Today our team will be presenting about CPU scheduling simulation which was developed using Java Swing. I would like to call forward Amay Gupta to explain about the FCFS algorithm.
So FCFS stands for first come first serve. In this algorithm, the CPU is allocated to execute the process that arrives first and then to the next in order of arrival. It cannot be interrupted regardless of the process is short or long. The process that enters first will be served first. Now we will see this with an example. Like we take some processes here, process 1 till process 6. Now we will start simulation. So here we can see like every process is executed in its order of arrival. Like process 1 was entered first, so it is executed first, then so on. So this is FCFS. It cannot be interrupted. Now I will pass on to Pranav Verma.
Algorithm, the processes with the smallest first time is selected. The principle on it works is that the shortest job gets the CPU first. It minimizes the average waiting time among all the processes. It requires knowing or estimating the CPU burst time beforehand. So let's see with the example on the graphical user interface. As we see that the Gantt chart is created on the screen. Now, now let's know how it works. The scheduler checks all the processes in the ready queue. It selects the one with the shortest burst time. The process runs until the execution, and after execution, the next shortest job is selected. Now let's talk about the advantages to it. The advantages are that it produces minimum average waiting time and is efficient for batch system. And its simple logic once burst times are known. Then disadvantages are it is difficult to predict burst time in advance, and it can also lead to starvation if the processes are very long. Therefore, it is not suitable for interactive systems. It is ideal for use cases in batch processing where execution time are predictable, and it is also used in simulation or controlled. Now I would like to pass on to Garg Rajkot for round robin scheduling.
I would like to explain about the round robin scheduling algorithm. The round robin scheduling algorithm consists of process like every other algorithm, and it has an additional feature of which is called as the time quantum. Time quantum refers to the amount of time a process can exist or run in the CPU. That means in round robin scheduling algorithm, the process enters the CPU, runs for the limited amount of time, then exists. Then the next process in queue enters the CPU, runs for the time, and exits the CPU. This continues until all processes are covered and no process is left. Uh, there are two types of round robin algorithm: preemptive and non-preemptive. I would like to explain round robin algorithm using non-preemptive version of it. Theoretically, it would be that once the process enters the CPU, it will not leave until and unless the process is completed. To explain this, I would like to run a simulation using round robin non-preemptive scheduling. As you can see here, process one uh, enters the CPU, runs according to its burst time, then exits. Then the next process in queue enters the CPU, runs, and then exits. This continues until and unless all processes are covered, and uh, the CPU gets empty. So due to this, we prefer round robin scheduling algorithm in preemptive type. That would allow all processes to run and cover the CPU time to time, and that would not lead to any kind of starvation and deadlock. Thank you so much.